These next two pieces are small, so I'll just go ahead and do them together. We have the basic principles of experimental design. Three basic principles: randomization, control groups, and replication. These are necessary to be able to talk about that causal relationship. One, randomization. We need to randomly assign people. If that's not happening, then we're losing that ability to have that causal language. We might as well be doing an observational study. So very important. It also reduces bias and makes sure that we are not choosing people that we might want in a particular group for some reason. Control groups. If we don't have a control group, we can't know whether or not the change that we're seeing is due to the actual treatment or not. I always give a silly example of this, of an old coworker who was obsessed with oil of oregano, and she was telling one of our other coworkers who had a dairy-induced ear infection that if she took oil of oregano, that would help. How she knew anything about dairy-induced ear infections and how oil of oregano would help them is obviously a moot point. I mean, there's no way she would know about this because I had never heard of a dairy-induced ear infection until this moment. But let's just say we wanted to test something like whether or not oil of oregano worked to help combat allergies. So everybody in the office is suffering allergies. We all take oil of oregano, and voila, a week later, all of our allergy suffering is down, right? Less sneezing, everything is better. All of our symptoms have gone down. Now, it's possible that the oil of oregano worked. It is this magical cure-all that my coworker said it was. It's also possible that something else is the reason this went down. It could be the placebo effect. It could be that pollen levels changed in that period of time. This is why we need a control group. Because as I did the last time, if we have this, we want to see that the control group, sure, they went down, but let's just say our treatment group went down more. If we do a control group and we find that everybody went down the same, well then it looks like there was something else that we didn't account for in our experiment that caused this, not the treatment itself. So you need a control group. And the last piece, replication. There's a really good video on science by, what's his name? John Oliver, which I'll post up in this section on Blackboard. So in the part 1 section, I'll post it up. All about replication and how in order to do a good experiment, we need to replicate the results and show that it continues to hold. There are a lot of experiments that get a ton of buzz and then nobody can replicate the results. One of which is the power posing. If you heard about power posing, which is like when you stand like this with your hands on your hips, looking all excited before you walk into something, that power posing somehow helped with performance. No one has been able to replicate the results of that study. So that right there is a big problem. If no one else can replicate it, then either they just happen to get some crazy results, they might have done something maybe not so okay when they did their analysis to get their results, but we need replication to show that it's not something that just happened by chance and that it happens again with another set of researchers. Unfortunately, there's not a lot of glory out there for replicating studies that have already been done, so you don't get that much replication these days. Okay, so last we'll just finish up exercise 1.6.4. As always, pause the video, try this out, see if you can do it, and then we'll come back and look at it together. All right, so 1.6.4 is one of my favorite questions to ask actually to the whole class because everybody gets a different answer, and then I let people talk and argue about it, and then they still get different answers. We just don't really come to a consensus here. So usually the questions, the answers that people are fighting between are A, C, and D. I don't get too many people choosing B. The reason is here, remember, anytime we're doing an experiment is because we randomly assigned people to something. And if you see here, we did have them use a new toothpaste, but it's missing the random assignment. So if you chose B, it was probably because there was no random assignment, right? That was part of our experiment. But if you look back, that is sort of what A is getting to, that there's no control group used, right? So you go, okay, well, they weren't randomly assigned. but they were assigned to do something, use a new toothpaste. The real answer here is D, because they are doing a matched pair design. This is a before and after. As you can see, we measured people at the beginning, and then their teeth were measured again. So it's our before and after, which is our matched pair design. So anytime you see that where we have something, we did make people do something, we have a treatment, but it wasn't randomly assigned, either this is the world's worst experiment, or you need to read carefully and see, was it a before and after study and a matched pair design?